What you're looking for is getting that x squared all by itself every time. So you're going to do whatever opposites are being done to it, like the inverse functions of that, so that you can get x squared by itself, and then you're just going to take the square root of both sides. And that's really what they're asking for when they're like, oh, solve by taking square roots. Let's look at some of these other, because it looks like there's a lot of example problems on here, so we might as well work our way through all of them, and then we'll do a few of the more complex ones so that you can see. So here we've got 4x squared equals 24, right? Oops, I forgot the square. It's not a very good problem if I forget the square. So right now, the only thing we've got going on with that x is that it's being multiplied by 4. So we're going to do the opposite of multiplication and divide that 4 out on both sides, right? Both sides of the equal sign. Otherwise, we mess with the equality, not inequality. And then we've got 24 divided by 4, which is just 6, right? And we're going to go, okay, well, let's just take the square root of this, right? Because when we take the square root of x squared, we're left with x. Now, the square root of 6 does not reduce. It gives us a funky decimal answer. So we would just leave this as plus or minus the square root of 6. These are what the zeros of this function are, right? Of this quadratic that we're solving. These x values are our zeros, right? There's two solutions there. One is plus the square root of 6, and the other one is minus the square root of 6, right? So you do have two solutions, which you need to have when you're dealing with a square function. There should be two answers. Could be two of the same solution, like in a perfect square, sometimes you get the same thing. But anytime you're dealing with when you're taking a square root like that, you're going to get a plus or minus solution, because you're looking at, like, to get a positive number, if I had two of the same negative number, it's going to give me a positive, right? And it, in the same respect, that if I multiplied two of a positive number, it would give me a positive number. So you're going to come across things like this too, where you like look at it and you break it down. You go, okay, well, 6 breaks down to 2 times 3, right? And there's no pairs in there that I can pull out. So we'll just leave it as the square root of 6. Does that make some sense? All right. Well, sometimes it's going to get like multiple things are going to happen, right? If you look at the example 3 that she did, where she had 2x squared minus 8. I think I know where she got these slides from too. I think I got a copy of these. I think I have this little slideshow presentation. So here, before, like, we just had one thing going on. Like on the first problem, we only had to move the 25 over. And then on this one, we only had to divide by 4 to get that x squared isolated. And this time we have the minus 8 being done to it and the 2x. You got to think about when you're isolating these things. I'm giving every detail because I don't know what you do and don't know, which is why I'm like trying to be as detailed as I can be. Dude, I'm down for all of it, so don't even I just want to make sure, like, I don't want to tell you too much so that we could cover more, but if I want to make sure you see every bit of it at the same time, so that you're not going back and looking at it later going, oh, what did she say there? So two things are happening here, right? We've got 2 being multiplied times x squared, and we have negative 8 being subtracted from it. So you're going to do your backwards PEMDAS, right? Like, because we're doing inverse operations, it's like doing PEMDAS backwards, and we're going to start undoing those things. And so I've got that 8 being subtracted, so I'm going to start by adding 8 to both sides, and I get the 2x squared equals 32 minus 8 is 24. It's late in the day. My math is not as good. I've been working a lot today. So we did that part, and the only thing left to do is to divide out that 2. And so we're just going to divide out that 2 from both sides. And then we've got that isolated x square that we're looking for, right? And so when we take the square root of both sides, here, when I subtract it, oh, dude, thank you. I see what you're saying. I was adding 8, not subtracting. Thank you. Nice catch. That should be 40. I was just testing you. That's all. I just want to see if you were paying attention. So now so we got 40, and then when we divide by 2, we get 20. So now I'm on the right track, I think. And so we're going to take the square root of both sides, right, so that we get that x. And now we kind of have to look at the makeup of 20, right? 20 is 4 times 5, right? And 4 is a perfect square, right? 4 is 2 times 2. So we can take that out as plus or minus 2, but that 5 has to stay under. And if you don't break it down, I don't know how strict she is on grading. So if you don't break it down, you'll probably lose some points. I'm guessing if she's into partial credit, you'd probably get some points for that if you had like plus or minus the square root of 20. But what you want to look for is you want to break it down into factors and see if there's any perfect squares in there that you could take out. Or even if you like looked at this and you thought, oh, well, I know it's 4 times 5, or I don't know it's 4 times 5, and I know it's 2 times 10, but then I know that 10 is 2 times 5, right? And you see that you have a pair, you know you can pull out a 2. Does that make some sense? All right. So there is that. Let's see what else we got here. Okay. Before we do that, in example 6, do you know how to handle that 1/4? 1/4 x squared minus 9 equals 0. It's example number 6 on the slides that you sent me. Hold on, let me switch. I could maybe I could show you. The problem itself is 1/4 x squared minus 9 equals 0. Yeah, you're going to move the 9 over first, and then you just multiply both sides by 4. Yeah. Okay. I just want to make sure before I skipped over that one. You've got solve the quadratic by taking the square roots. You have one where you have x minus 5 squared minus 4 equals 8. Do you know how to handle that one? Let's go through it really quick because it doesn't hurt to do it, right? So with this one, you're going to start just isolating this square root. This whole thing is your square root. So you just want this to be the only thing on the side of the equal sign right now. And so you're going to start by just adding 4 to both sides. And I'm not going to mess up the math this time. You know, x minus 5 squared equals 12, right? Right there. And so now I'm going to take the square root of this and the square root of this. Because what it does is it just gives me what's inside the parentheses. So I'm left with x minus 5 equals plus or minus the square root of 12, right? But we don't care what x minus 5 equals. We only care what x equals. So I'm going to just add that 5 to both sides. And I'm going to have x equals 5 plus or minus the square root of 12. And now we got to break down the square root of 12, which again, was like 4 times 3. So we could pull that 2 out, and we get 5 plus or minus. We're pulling a 2 out of this, right? And the square root of 3 has to go back. So that's where you get those ugly numbers that you see a lot when you're doing the math, is it's just square roots that can't break down. And I know they kind of look crazy when you have that 5 plus or minus thing going on. But don't worry about it. You don't have to combine them. You don't have to figure out that decimal number. Solve the quadratic by taking square roots. So that's the same. It's taking square roots still. Let me go to the other ones because that looks like, I think the other slideshow is the one where it was looking for the zeros. Oops, I clicked the same one again. Yeah, this is the right one. Perfect square roots. This one's teaching you about square roots. That's actually a really good beginning thing because it's just square roots. But where is the one that you sent me that had the zeros in it? I think oh wait, I found the attachment you sent. Okay. It's just a paper with a bunch of problems on it. Yeah, okay. So solve using the square root method. That's exactly what we were just doing, right? Yeah, like well, I mean, some of the stuff, the solve using the square root method was just what we were doing. It was like x squared minus 45 equals 4. And we're going to do the same thing where you're going to isolate the square root. Where she's talking about solve to find the zeros, how much factoring have you guys done? Do you know? Ooh, that is rough, man. That is rough for you. So this is solve to find the zeros, which means that this isn't factorable. I mean it isn't you can't solve using the square roots. There's only 2 things you can do. Well, 3. You can complete the square, which you don't want to do. Or you can factor, which might work on this one. Or you can do the quadratic formula. Now it doesn't say what method she's used. And I know that they did the quadratic formula in your class. Did you do the quadratic formula though at all? Because I wonder if she provides you with because it's x equals minus b plus or minus b squared minus 4ac over 2a. And you kind of just have to know what to fill into the blanks there. Are you going to get a test review? Like, is she going to give you a review to work on for like problems that might be on the kind of problems that might be on the test? Okay. Well, let's definitely put the quadratic formula on that. Um, I want to see like the kind of stuff that you've been working because I want to make sure I give you a good foundation going into it, with the kind of problems that you'll need. So with this one where we solve to find the zeros, like I would factor this. I think we can. Um, and there's some things to remember about factoring that, like if I have a negative right here, my factors, one will be positive and one will be negative. And the reason I know that is that these 2 end numbers are going to multiply together at the end to make this. end piece right here. And you can't have a negative number at the end unless you're multiplying a negative times a positive, right? It's not possible at all, right? So if you have a negative at the end, one of your factors will be positive, one of your factors will be negative. And I'm going to make you a little sheet for the next time I see you, okay? Which we'll try and meet earlier in the week next week. We'll try and get some time in, even if like we have to do it like in the afternoon or something like that, after school hours, whatever works for you. If it's hard to get away like during this period more than once. Um, but I'm going to make you a little sheet and it's going to talk about factoring and certain things that you can know when you're factoring. And one of those things is if I have like an ax squared plus bx plus c term and it equals 0, I know my factors are both going to be positive, right? Because everything in here is positive, right? If I have ax squared minus bx plus c equals 0, both of my terms are going to be negative, right? And the reason I know that is that this is negative, but this is positive. And so I can't have a negative here and a positive here unless both of these are negative. When I multiply these two end pieces together, two negatives make a positive. You don't have to memorize all that because we're going to make you a little cheat sheet so that when you look at the problem, right, and the way that it's set up, you'll know what kind of factors that you're going to have. But what we really want to do is get you comfortable with that quadratic formula. But no worries. Let's try and make some time for early next week, okay? Because I know that it's hard to squeeze it in this amount of time. What time do you get out? Like, can you get out for this? Or would it be better if we did this like in the afternoon? Yeah.